Now that you know what the graph of tangent and cotangent looks like, now we want to talk about their translations. So we're going to look at their general form. Notice it's very similar to our general form for sine and cosine, with the a tangent bx plus c plus d and y equals a cotangent bx plus c plus d. Once again, we're going to look at amplitude. Amplitude is still going to be vertically stretching or compressing, and it is going to be absolute value of A. Amplitude is harder to recognize with tangent and cotangent. The graphs don't look as different since I'm just pulling up faster as opposed to taking that curve and smashing it down or pulling it up. The period is still going to be the distance for one complete cycle. It's going to fall between two vertical asymptotes. So oftentimes you'll be asked to find the vertical asymptotes. The formula for period, if you think about with sine and cosine, we took the traditional period of 2 pi and we divided by b. Well, if you look at your graphs of tangent and cotangent that you made from the previous video, notice that tangent and cotangent have a period of pi as opposed to pi over 2. So for that reason, our formula is going to change slightly, and it's going to be pi over the absolute value of b instead of 2 pi over the absolute value of b. Our phase shift, it's going to move the function left or right. We're going to keep the same phase shift. It's still going to be negative c over the absolute value of b, so that's not changing. However, when we find our interval, rather than say, oh, I can just take 0 and I can take, my new interval and add or subtract my phase shift to it, because we don't have that nice starting point of 0, we're actually going to take our kind of normal interval, which would be between negative pi over 2 and pi over 2 for tangent. And I'm going to go ahead and take this bx plus c, since that's what affects my period and my phase shift. And I'm going to solve this compound inequality to find my new interval for one period. Oftentimes, this is also be referred to as finding my vertical asymptotes. I'll do the same thing with cotangent, except for the quote-unquote normal interval for a vertical asymptote for cotangent falls between 0 and pi instead of negative pi over 2 and pi over 2. And again, I'm just pulling that from their traditional graphs. If you look at those, where do those vertical asymptotes fall? And again, that D is going to be your vertical shift. So I think I have 3 examples here, so let's go ahead and look at the first one. I'm asked to find period, phase shift, and vertical asymptotes for tangent of 2x. Oftentimes with tangent and cotangent, I don't have to find as much. So my period is now going to be pi over the absolute value of b. So again, changing that formula just a bit. My b is 2. B is still in front of the x, so my period's pi over 2. My phase shift will be negative c over absolute value of b. Well, notice I don't have a c here, so my phase shift's going to be 0. And then to find my vertical asymptotes, which again is the same thing as finding my interval, I'm going to go ahead and take negative pi over 2, since it's tangent, is less than 2x is less than pi over 2. So I see in order to solve this inequality, I'm going to have to divide by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. So I'm going to multiply here by 1/2, here by 1/2, and here by 1/2, giving me vertical asymptotes at negative pi over 4 and pi over 4. So all I'm going to do is I'm going to draw in my vertical asymptote at negative pi over 4. Remember, that falls halfway between negative pi over 2 and 0. And at pi over 4, falling halfway between 0 and pi over 2. And then in the middle of my vertical asymptotes, I'm going to place my intercept, and then I'm just going to go ahead and draw in that same curve that we looked at in the previous video, approaching those vertical asymptotes. And now all I do is I shift over a period of pi over 2. So I'm going to take this intercept, and I'm going to go over pi over 2, and I'm going to make my next intercept. Same thing, I'm going to go over pi over 2 from my asymptote here and make my next one. And then I can draw in that next cycle. Same thing, over a distance of pi over 2 on both the intercept and the asymptote, and draw in, again, that next cycle. So here are 3 cycles. I could continue going. I could do as many cycles as I wanted to do. Traditionally, you'll be asked to do 2. Let's go ahead and look at the next example. I'm going to do the same thing. So first thing I'm going to do is find my amplitude. Notice now I'm working with cotangent. So my amplitude is still absolute value of A. So absolute value of 2 is just 2. I will find my period, which, remember, is going to be pi over absolute value of B. So I get pi over 2. And my phase shift, which is going to be negative C over absolute value of B, which gives me negative pi over 2 over 2. And then from here, I need to solve that interval. Remember, the interval now is cotangent, not tangent. So instead of going between negative pi over 2 and pi over 2, I'm going to solve between 0 and pi. So the first thing I'm going to do is I'm going to subtract pi from each side, giving me negative pi is less than 2x is less than 0. I'll divide by 2, giving me vertical asymptotes at negative pi over 2 is less than x is less than 0 divided by 2 is still 0. So my interval is going to, or my asymptotes are going to be at negative pi over 2 and 0. So I'm going to go ahead and draw those asymptotes in. And halfway in between, I'm going to go ahead and put my intercept. And then just remember, cotangent starts at the top and comes down. And then I'm going to shift over pi over 2 from each, pi over 2 from my intercept, and pi over 2 from my asymptote. Put that in. Again, cotangent starts at the top and comes straight down. There's my second cycle. Again, I'll go a distance of pi over 2. And a distance of pi over 2 on my intercept. And again, there's 3 cycles of my cotangent graph. We'll go ahead and look at one more example with tangent. This is a great one for you to try at this point. This will be the final example. All right, so first thing I have to do is find my period. So again, it's going to be pi over absolute value of B. So I'm going to have my B is 1 in this case, so my period is pi. Next thing it asks me to find is my interval, so I'm not asked to find too much here. So then when I find my interval, it's now tangent again, so I'm going to go ahead and say negative pi over 2 is less than x minus 3 pi over 2 is less than pi over 2. So I'll add 3 pi over 2 to each side or each piece. Putting my new asymptotes at 2 pi, this is going to give me 2 pi over 2 here. Negative pi and positive 3. 2 pi over 2 is going to reduce to pi. This here is going to give me 4 pi over 2. 4 pi over 2 will reduce to 2 pi. And then I'm going to go ahead and draw my asymptotes in at pi and 2 pi. And in the middle of them, I'll put my intercept. And then again, it's tangent, so I want to be an increasing function. And then I'm going to go over a distance of pi, and I'm going to put another intercept. I'm also going to go over a distance of pi for my asymptote and put another asymptote. So a distance of pi for my intercept and a distance of pi for my asymptote. Again, it's tangent, so it's an increasing function. I can also put another cycle in going back. So again, back a distance of pi for my asymptote and back a distance of pi for my intercept. And again, I just draw in my increasing function. So big thing to remember with tangent and cotangent is we've slightly changed the formula for the period, and we've also changed our formula for finding our interval, also referred to as finding our asymptotes.